Good evening, students. Trust you are doing okay. Yeah, I'll continue from where I stopped. Yeah, it's still going to be continuation of SS1 work in physics. SS1 work in physics. And this is going to be the next topic, and that has to do with measurements and units. Okay, measurements and units. Okay, so in physics, actually, we do not joke with measurements because measurement are actually the basic way of communication in physics. And that's why when you solve question and you do not put the appropriate units, you discover that you are penalized for it. Okay, so that is also important for you to note. Now, we have what we call the quantities, we have what we call the units. Okay, so basically, we say that uh, units actually are used to express measured physical quantities. Okay, units are usually used to express measured physical quantity. For example, uh, you have length, right? Length is a quantity. What's the unit of length? Is meter. You have mass, for example. What's the unit of mass? Is kilogram. You have time as quantity, for example. What's the unit of time? Is second. Okay, so the SI units are actually the principal unit that we use today in our scientific work. Okay, so, and I'd mentioned your length, I'd mentioned mass, I'd also mentioned time. Okay, these are basic quantities. Okay, actually, we have what we call the fundamental quantity. There are seven of them. There are seven of them. Let me quickly run through that quickly. The seven fundamental quantity, and I'm going to tell you what fundamental quantities are. Okay, for example, your mass is fundamental quantity, your length is fundamental quantity, your time is also fundamental quantity, your amount of substance, okay, is fundamental quantity. Let me write it in full. Substance. Okay, your current is fundamental quantity, your luminous intensity is also fundamental quantity. They are about seven. They are about seven. Your temperature, yes, I remember now. Your temperature is also a fundamental quantity. And each of these fundamental quantity, they have units. For example, what is the fundamental unit of mass? It is kilogram. What is that of length? The length now is meter m. What is that of, okay, let me put the recording here. What is that of time? Of course, you know that time is seconds. Okay, second. What is that of temperature? Temperature obviously will be what? Kelvin. Kelvin. So let me use capital K. And then what of current? Current is ampere. 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 I use A. Ampere. And then what of amount of substance? Amount of substance. I don't want to write it in full. Amount of substance, it is what we call mole. So you abbreviate it mole. And then what of luminous intensity? Luminous intensity. Luminous intensity is what we call candela. The unit is candela, which is CD. Okay, so you can see now, I think, have I omitted anyone? Yes. So those are the various units. So what are fundamental quantity? We say that fundamental quantities are those basic quantities. They are quantities that are independent of others. You can't derive it from others. They cannot be gotten from others. They are independent. They are basic quantities. And these seven quantities I mentioned are the fundamental quantities. Okay, and the units attached are the fundamental or basic units that we have. Okay, now the next thing you may need to know is the derived. As we have fundamental, we also have what we call or what is called derived units. Okay, we have what is called derived unit or derived quantity. Okay, derived. This one now they are derived from fundamental, derived quantities, and also derived what? Derived unit and derived units. Okay, derived unit and quantity. So as we have fundamental quantity, we also have fundamental derived quantity and derived unit. Okay, and we have quite a good number of them. I will just give you a few. For example, our area is a what? Is a derived unit, a derived quantity rather. And what is the unit of area? You know, is meter square. Of course, you know that meter square. Okay, so it means that area generally as a derived is length times either length or length times what we call breadth or width. I'm sure you know that. Now look at volume for example. Volume is also a derived. You could say length times breadth like times height, and so the unit is meter cube. You could use density. What is density? Density is mass what over volume. Mass over what? Over volume. And if density is mass over volume, now if you see now that the kilogram is the is that of what? Mass. And then this one is meter cube. Therefore, we can say the unit of density is this. Or from law of indices, you could take this one up and this one becomes 3. Instead of putting this bar, you could put minus 3. It's allowed. So that becomes the unit. So this one becomes the unit of for the density. You could go ahead and say velocity. Velocity is also a derived quantity. And what is velocity? Velocity is displacement over time. Okay, displacement over time. Displacement over time. We are still coming to motion, so you will know that fully. And that is meter. Displacement is meter and time is seconds. So at the end of the day, your velocity is meter per second, or you can write it like this, that meter per second. So you have it this way. I'm sure this is so clear, right? This is very clear. So let me wipe this part of the board while you are still taking care of the other side. Okay, so there are so many of them. You have acceleration too as a derived acceleration. What is acceleration? You know that acceleration is what? Is velocity over what? Velocity over time. So you have velocity over time, and then velocity, we just did that now. That is this over time second. By the time you take this up now from the law of indices, it becomes something like this. Okay, that is, you're taking the denominator up. It becomes minus 1 minus 1 minus 1, that's minus 2. So our acceleration is usually mx minus 2, or we say meter per second square. So this and this are the same in mathematics. It is allowed. They are the same. Okay, take note of that. Okay, so now I could just continue like that to begin to show you the various derived units and derived quantity as a case maybe, but I'm going to stop there. Okay, I'm going to stop there because I'm still going to look at dimension if time will permit. So uncertainty in measurements, uncertainty. So measurement actually play a crucial role in physics, but can never be perfectly precise due to number one, imperfection of human judgment, number two, instrumental defects, and then what we call limitation. Number three, there could be a kind of variability of quantity being used. So if you have the quantity that are being used and the various variable around the quantity, that can also affect the correctness of the measurement. Okay, it can affect the correctness of the measurement. Now this is so important for you to note. Now there is what we call the uncertainty of an instrument. Okay, the uncertainty of an instrument is the least measurement it can determine. Okay, the least, usually this is actually half of the smallest division on its scale. So the uncertainty of a meter rule, we usually say that the uncertainty of a meter rule is usually 0.05 centimeter, or what we call 0.1 centimeter, either 0.05 or 0.01 to one decimal place. That is to one decimal place. So what that means is that if you want to record a length of, let's say, 52 centimeter, so a length of 52 centimeter could be recorded within the range. It could be recorded within the range of 51 to 5 centimeter. Sorry, 51.9 centimeter, and could be recorded to 52.1 centimeter. Remember, we said that the uncertainty, the measurement, we told you of, I just told you of meter now, that it is 0.05 centimeter to 0.01. Okay, so you want to measure this now, and then you could take it either this way, 51.9, or you take it to what, to 52.1. And for this reason, all measurements in physics are usually stated within a range that contain the correct value. Yes. So that is one thing you need to note very carefully. Okay, very, very important. So we have what we call the uncertainty. Talking about the error of a measurement, is we usually specify it either by stating it directly, or you know or we use a notation, okay, to state it. So we usually use a notation to state it. Okay, so and that's why if you are given a question in exam, let's say for example you are given this kind of question. I just few days ago I was teaching my student percentage error. Look at this. For example, they say, let's say they say find the percentage error in the width of a rectangular by 7.3 plus minus 0.1 centimeter. So you have a situation like this. So in this case now, and normally we usually have the formula percentage error is equals to error over the actual value times 100. So we have 0.1 over 7 this multiplied by 100, and whatever you have, multiply it by this, and then multiply it by this, you get whatever you have become your final answer. Let's just quickly do that together. Let me multiply that. So I have 0.1 multiplying 100, and then dividing by this. So you have 7.3 divided by 7.3, and that's giving me 1.699. So let me take it approximately 1.37 to 2 decimal percentage. Okay, so that's what you have right there, and you can see that it's very simple. Okay. Okay, so and I'm sure you do not have any issue with conversion. Okay, conversion, how to convert meter to centimeter, centimeter to meter, and all of that. You shouldn't have any issue. I don't think there should be problem with that at all, because we know that 1 kilometer is equals to 1,000 centimeter, 1,000 meters, pardon please. And then we also know that 1 hour is equals to 60 minutes, and in terms of seconds is 3,600 seconds. So what that means is that if I give you, let's say, 36 kilometer per hour, and you are supposed to convert it to meter per second, what you are simply to do, please let me wipe the board so that you get that clearly. If I were to give you, let's say, 36 kilometer per hour, and you are to convert to meter per second, remember I just said now that 1 kilometer equals to 1,000 meters, so that will give you 36 times 1,000 kilometer. And then I told you that 1 hour is the same thing as 3,600 seconds, so which is 60 times 60. And then by the time you do that correctly, you have 10 meter per second. How? Cancel this 0 to this 0, cancel this 0 with this 0. 6 times 6, 36, and that will take care of this 36 up here. So you are left with this 10, and that is the answer to your question. I'm sure that is very simple. Okay, till I come your way again, I remain my humble self, Yomi Omorewa. God bless you. Bye.